Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born, the first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.
So, hi everybody. We are back to doing a physical event. I just have a quick warning. Please step away from Sergio since he is radioactive right now. If you start hearing coughing, please leave the building orderly. Oh, I don't have to point this. So we are back. We'll have our 96th meetup. If everything goes well, starting today there will be physical events. And today we'll received a talk from Pedro called From the Ground Up, Building a Data Science Team. Instead of having a circle talk, we'll have a new event called Breakout Session where we are going to discuss the topics brought during the talk. So the agenda for today that is completely wrong right now is the welcome and get together. Let's assume that this was being done, and I have 2 minutes to finish this. We will start his talk. We'll do a group photo, we'll have a network, and then we have the breakout session, the new part. And everyone that wants to join us can have dinner, and you have a link to fill the form.
I think we should have a QR code suggestion for next time.
Thank you. I hope COVID hurts you really bad. Right? Most of you should know, but this is our mission. We are an informal group that want to share knowledge regarding data science. You can either be a professional or a beginner. If you want to know anything regarding data science, you can be part of our group, and we will do the best to provide this kind of event to share our expertise. We promote some things, mostly knowledge sharing and open events for everybody. We do not want is people selling out in events, sharing information, trying to hire people. Are you okay?
I'm still alive.
Damn it. And we have a call for proposals. If you have done something or you know someone that has done something in machine learning that you want to share in these events, you just use this QR code. We have a QR code.
Fast learners.
See? You fill in the form and we'll evaluate your proposal. You are divided in these 5 cities: Aveiro, Braga, Coimbra, Lisbon, and Porto. And Aveiro is the first one that break out the COVID events. We have a portal where you can find our next events and job proposals. Hopefully it's updated right now. And we have all of these social networks where you can find us and talk with us. We'll get the QR code next time. I want to thank Bosch and the engineering group for organizing this. I'm sorry I don't know all the names of people involved, but I want to thank them in the name of DSPT for giving the space for this event. Without further ado, we'll welcome Pedro. He was a lead data scientist at Altis.
Yes,
right?
was. Yeah.
He's in the process of evolving, let's call it evolving. And he's going to talk us about from the ground up building a data science team. And the floor is yours.
Okay, thank you. So before we start, I just want to ask for everyone to mute your microphones and turn off your cameras. wait, we have real people today. But jokes aside, I want to thank DSPT to call me and for me to have some space to share something with this community that I've been following from a long time now. And so I bring here basically the journey of our team, how we got started, and some things that we may want to think about when building some sort of data team. So I'll talk about three different things. First, getting into data science. Then the main topic is, building some sort of team to solve data challenges, and then I'll talk about data strategy very quickly, and then we finish off with some takeaways. And so the first thing in a lot of meetups, there's usually a lot of questions like, how can I get into data science? What kind of path should I have? Where should I go? But the answer actually is that there's a lot of different ways to actually skin some sort of any kind of something that has skin. Doesn't have to be a cat. But what you should think about is where do you want to go instead of I want to become a data scientist. Ask yourself which kind of data science do you want to be. Maybe you work in some sort of biology field and you want to use data science. So maybe you don't need to go into comp sci. You just have to go, do a coding boot camp and then get into data science. But if you want to go further, if you want to use more technology and create new stuff, new models, maybe you should consider spending 5 years and some money going into computer science. Building the team, and hopefully with this, I won't get any questions like what is the best path. And so the second topic is building some sort of team. And for this, I have to talk about 4 different things. So the first is methodology, then roles, then some sort of planning, some sort of scheduling of tasks, and then the technology that makes all of this work. For us, for our team, methodology is about some sort of principles that allow us to have some sort of life cycle to do data science. It's some sort of mental structure for us to do our work. It should take on the technical side and the non-technical side of doing data science. And you should set some sort of standards for people working with data to know how to do stuff. And then maybe we have some ideas on creating some sort of toolkit for us to do data science a bit quicker. There's a lot of references. I won't go through every single one of them. You have KDD, you have CrispDM. These are a bit older and a bit focused on data mining. And then you have TDSP, which is the Team Data Science Process from Microsoft, which builds upon the idea of CrispDM, and then it provides some sort of modern take on the data science lifecycle. And so what we did was to derive our own. And this is what you see here, some sort of data-centric lifecycle that you can go through all the loops in order to do data science. So usually you start with, you always start with business understanding, so that you can frame the problem, so that you can learn about the domain of the problem that you're trying to solve. And then you get into defining your targets, defining what it means to have success, what kind of metrics can we use, and define where is the data and can we get to it. As soon as you have that, you can go to the data acquisition and transformation stage. This is where you do all of your data work. You get to build pipelines. You get to plot 100 different pie charts that no one looks at it, and then you can prepare data set clean and build those data sets so that you can go into modeling. And modeling is what most data scientists want to do, which is train models, select features, drop some of them, create 351 new features, and then break all the RAM that you have to use, and choose the type of models that make sense for the kind of work that you're trying to do, and train and evaluate. As soon as you take a look into the model performance, then you sit at this crossroad. Because if you don't have enough good performance, you have to go back into the other stages to try to find out what is the problem. Is it within the data? Did I get something wrong from the actual domain? And so you have to go back. If you don't, and if everything is okay, then you go into deployment, you build those nice layers of software fat around your model, and then you deploy your own stuff, and hopefully you have some sort of supervision of the things that are actually running. And that's what we have derived from those references. This is what we've been using for the past 4 years. This is what it makes sense for us. The second topic is roles. And roles, there are plenty. It really depends on the type of teams that you might have. It depends on what your company is trying to do. But you have classic roles like data scientists and software devs and data science managers and so on, and project leads. You have other roles that no one really knows what they are, like data mastermind or cognitive champion. But if you search for them, they're somewhere out there. And you have other roles like data journalist, which is very awesome, and it's some sort of person that can help you bring out the value that you have with a story to tell in data. But in order to understand how the life cycle works, I have this image which provides some way for us to build a solid data team. This is the title of the article, but really showcases that there are a lot of different roles doing different things with data. And so I cannot point here, so I'm just use my finger. You have 6 different levels, right? You have the black level, which is managing tasks and all of that. You have Scrum Master and product owner. We don't really care about those. They just make us work. They don't actually do any sort of work. Sorry. And then you have the red line over here, which is about asking questions to data and getting answers to business people, right? So you have business manager, data analysts, and so on. And then you have the actual work, which is the work that we do, which is work with data. You have data scientists using the data sets that the data engineers produced to find some sort of solution, most likely with machine learning. And as soon as they find something that can be used, then they have to talk with the roles down below in the orange and green lines, which are basically the roles that take all of those models that we put somewhere and deploy them into production, right? And then you have the purple lines, which is basically BI roles, which are trying to find out how much money are we making, where can we go from there. And so roles in practice really depend on the team structure that you have and what your company is trying to do. So in product teams that build products with machine learning and some sort of models and so on, you have a more complete set of structure with roles from dev and from data and roles from data, right? But you might have different structures. You might have research teams with data roles and scientists and research scientists and so on. And you have teams like mine, like data science only team, which only has data roles, because what we do is work transversally with other business units to build machine learning features on their products, not on our product, because we don't have any sort of product. And so roles really depend on what you're trying to build. So choose what makes sense for you. Work plan. In work plan, it's about planning some sort of structure for us to do our work. I have to talk about two different things. So first is actually planning some sort of schedule, and then design thinking. This will make more sense. This one is hard to see. Usually the work that we do is based on POC. So for us trying to prove some sort of concept, basically making sure that we can solve that problem using machine learning. And so for us, we start with a design thinking workshop. We sit everyone together and frame the problem, and sitting everyone together means us, the data scientists and other roles, but also business people. And then we define a structure of 6 weeks with 3 different sprints and 4 different streams. So we divide the team into different streams. We start with stream number 1, which is basically the EDA phase, where we take the data and we look at it. Stream number 2 is about data prep, preparing data sets, cleaning data, and so on. And stream number 3 is about training, modeling, so on. And if we have resources, we go into stream number 4, where we basically have some sort of data journalist for us to build a storyline and tell the story and translate the value that we are trying to bring into actual business. So this usually takes 6 weeks. And if we find out that we can solve that problem, then we move into other stages of making it run to deploy these models into other products. That may take up to 6 to 8 weeks. I think nowadays we can make it faster because we have a lot more technology. And so I talked about design thinking, right? Sorry. So design thinking for us is a way to kickstart the first stage that we have. So business understanding. So sitting down with stakeholders and have some sort of workshop to work out the problems that we are trying to solve. This is something that was given to us in a joint project a few years ago with IBM data science team, and they brought a data journalist, which helped guide this workshop in defining the problem that we have to solve, sitting down with the stakeholders and taking a look into the data that we can or cannot use, where it is stored, and then defining with the business people, and that's the tricky part, having the business people actually talking about data and framing the vision and the problem statements and what it means to have success from a technical point of view and from a business point of view in terms of money, right? So we have to translate those metrics into something that makes sense. And then it's about doing stuff and then communicating. And so if you start doing something like this, you get something like this whiteboard, right? You start drawing what the domain has in terms of people, in terms of data, in terms of systems, in terms of teams, and then you start finding out the pain points that they have, the sort of problems that you can go into and solve them, right? And so you start seeing that you have different domains of different things, and then you start looking into the data to figure out what kind of data do they have, in what sort of systems, in what sort of formats can we use it, and so on. But the most important part is that you sit down with business people and make them write post-its that they feel comfortable in terms of framing some sort of problem. And so it's hard to read, but you make them write that they need a way to solve something for them or for someone else, and they struggle because of something that they write there. So they write their own problems there. And then you get to define the actual problem and what it means to have success. And having success isn't just having any kind of model or a model with good performance. You have to write down what it means to have good performance. And for some people, it's about minimizing the cost of false positives. And for others, it's about having 85% of precision or any other sort of metric. But the key is that you really have to make them listen and write those post-its. That's the hard part. Okay, so technology side of things. This is what I like the most, right? For us, it's about creating some sort of toolkit for data science. So we started with nothing, and we need some sort of basis. It can be any sort of closed source or open source or cloud or on our premises. But we need to find something that helps us set a standard way of working so that everyone uses the same technology or similar things. Ensure that everything that we do, all the artifacts that we actually produce are versioned. Okay, this is a key point. And then streamlining, so building all the technology and the automation that we need to make things faster and better. And then aligning ourselves with the rest of the world, because we don't want to become some sort of silo of technology and data. We want to stay open to other stuff. And so I want to talk about 4 different things. So first one is structuring our projects. The second one is versioning. The third one is about streamlining, so some sort of framework for us to work with. And then a few ideas on deploying models. So project structure, you have a few options. I won't go through all of them. We use Cookie Cutter for data science, which is basically a template, a Python template for data science projects. And it gives you a place to put your data, your documentation, your models, your notebooks, your references, your reports, figures, and so on. And if you look at the right side, you see that you have some source code, which means that you have to step down from your notebooks and actually build some sort of robust code base for your data pipelines, for your features, for your models, and so on. That's what we use. Versioning. Nowadays, there's no excuses for not versioning the stuff that you do, and it's not just code or data or models. It's everything. So please do not use Dropbox or Google Drive to share code, to share data, and to share models. I've seen some things in the past, and it's not great. So there's a lot of technology for code. I mean, you all know this. You can use Git. You can use, if you are a bit older, you can use Subversion. Please don't. If you, for data, you have things like DVC, you have things like weight and biases, which gives you a way to version data pipelines. And for models, you have open source tools like MLflow, which we love and use to track everything that we do with models and compare different models and so on. But you also have closed source stuff like Neptune that you can buy if you want to spend money, because there's cool stuff that you don't need to spend money on. And streamlining means that we have to build some sort of framework for us to work with data. And so this is the kind of stuff that we've been building. Some of the stuff that it's here we actually use, and some of it is just a way to showcase other technologies. So usually what we have is source systems that have data. We get data from there with data sources, and everything goes through a streaming layer. The streaming layer has a message bus. We use Kafka, and then we have all our data pipelines next to it, right? We use PySpark, we use Python. We don't really use Flume, but we use PySpark and we use Python for some pipelines for us to get data into the storage and the serving layer. So the serving layer wants to give you some sort of storage for you to put your data, and the serving layer wants for you to have some sort of way to get data in a standard way. So what we usually have in data lakes, you can have MinIO and then Presto, which gives you a SQL API for you to work with. But the idea is that you put technology down so that you can store and access data. And you want access to data because on top of that you put your tools, you put your Jupyters, you put your Seldoms for deploying models, and you want to connect to data because you have to get data, you have to get models from somewhere. And in dashboards and reports, you may want to visualize data. So we use Superset, but you can also connect other tools like Tableau or ClickView or Power BI. It doesn't really matter because the API is always the same. So this is the stuff that we want to build. On the other end, you have streaming use cases like online machine learning or event-based processes with triggers and stuff like that. And you can directly connect and skip all the layers, and you can go directly to the messaging bus. So you have all the options that you might want for you to do any kind of data work. You can also use Flink for streaming apps or any sorts of processing that you might need in near real time.
Sorry.
Yeah.
Is this infrastructure all on prem, or do you have any layer on cloud or anything?
Everything is on-prem. I have a figure that I can show you later on, but everything is on-prem. It's company policy. We have to use it. I'm sure you know really well what I mean. And, so this is what we have to work with, right? So you have a framework for you to work with data, and as soon as you do and you train your models and so on, you want to move into deploying. And deploying means that we have to solve this problem. And the problem is that even if you version your data and your models, usually the data science work that people do, it's kind of loose. It's notebooks, it's scripts scrambled all over the place. And even if you version your models, you have to get the models, you have to get data, you have to get the notebooks that did some sort of weird pre-processing, and you have to rewrite code in order for you to build some sort of service. You basically want to build a service that takes some models, some data, some logic, some weird pre-processing and build something that answers to prediction requests. And what we've been building in my team is something similar to this. So in order to us to move a little bit faster, to do projects a little bit faster, we want to build some sort of service composer that we still don't have it, but we've built other pieces. And the idea is that you may want to serve various models for different things, even for the same project. Imagine that you have some sort of car project and you want to have models for sports cars, and you have Model B for trucks and so on. And we want to have a quick way to configure some sort of routing system so that we can have different types of cars with different types of models, have some load balancing so that we can scale, and then deploy all the models with standard APIs for us to call predict, And in some cases, we actually have to also serve data, because the data pipelines might be ours, and the client doesn't really have the data. Maybe he just has some sort of serial number that he wants to call a prediction on, and so we have to fetch all the sensor data and all the data that we might need to call some sort of model. So we've built a few of these boxes, and I think it's one way to go, given the technology that we have to use.
So,
yeah.
Sorry.
Sure.
Those boxes will be a completely different technology used. So you're probably using Python inside each Docker to.
Yeah.
Okay.
Yeah.
So you move completely the part of Kafka Flink.
Yeah. Yeah.
Okay.
In this case, we had to do that in some of the projects. You could also say that, okay, but if everything is streaming and you have a data framework that is streaming, why are you going for this? It's a good question. I don't have a good answer for that. You could also build this with topics, with some sort of messaging bus. This is the way that we did because of the other products that we have to talk with. Actually, in the past, we had streaming models connected to a Kafka topic, but over time, we had to go to this sort of solution.
This is only for model processing, right?
Yeah. So call prediction. I don't care about anything else. The data has to be pre-processed. The data has to be in the exact format that the model wants to have. Okay. Any more questions here? Okay, so the next slide, it's what we've been building over the past years. It's a bit chaotic. It's Kubernetes, and everything is open source, deployed on top of K8s, basically. The data lake stands outside. It's not ours. But we have all the technology necessary to do data science. So we have Jupyter Hub with where every user has its own Jupyter lab. And then we have tools like Spark. We have all different databases, MinIO, which gives us a place to store stuff with an S3 API. And we have monitoring stacks. We have Elk. We have a place to put documentation with Docat. We have our CI/CD pipelines, and so on. And then on the same space, we are able to actually have other pipelines or other data pipelines that have to run here. And we have also another place to put our models into production and actually connect to other tools to get data. So we may have a model serving that is reading a model from MinIO, or getting data from the data lake, or getting data from any other database and doing its logging into Logstash, and so on. So the idea was to build this over time and choose the technology that works for us. Okay, so the last topic, and yeah, I'm still on time, great. I want to talk about data strategy. This is a hard topic to talk about because there isn't really much out there. There's some ideas, but for me, data strategy is some sort of foundation for everything that we do with data. So it's the foundation of all data practices, right? It's about building and changing the mindset. So trying to build a data-driven culture, which is something that a lot of companies, especially big companies, are missing. It's some sort of strategy to use data. And this is what we found out in our own company, that you need a leadership to put things working. And so it's about having this long-term plan that defines people, processes, and all the tech that you may need to solve problems, but actually support the business. It's not just about putting technology and solving challenges, right? And so why do we need this? Because a lot of companies are failing to do so, are badly behind the curve. A lot of people have access to data that they shouldn't have. And I know some people in the audience that they know that they have access to data that they shouldn't have. And because there's a lot of legacy technology, and it's hard to get value from data projects sometimes, or every time. And it's about solving this last problem that every project usually takes these data challenges as a one-off thing and solves that problem for their own people, but not for everyone else. And so we have to think in a different scope, and we have to train people to think in a different way. And so it's about looking at the data in a different way. So data usually is a byproduct of some sort of product that we sell, but should be looked at as a business asset, something that can be used to be transformed into something else that can be used to drive business decisions and build AI products, if that's the path that your company wants to take, which usually is, because that's what it's selling in this year, right? And so for me, it's about defining this sort of 5 pillars. You usually start with some sort of vision. You define what the kind of business strategy you may want to have, what kind of value do you want to take out from there. You define those goals, and then you go into governance. You lay down the structure that you need to manage data. So who has access to what kind of data, when, how, where, and so on. And then you move into the tech side of things. You work with, you build some sort of data framework, or you buy one. And choose a technology that people will have to use to work with data. And then, the trickier part is people and culture, because you have to sit down with people. You have to build this data-driven mindset, which means that you have to train people. You have to work on literacy on data, on how critical data is, not just on using, because it's about producing high quality data. Is not just having some sort of system that puts data out. You have to take a look at it and ensure that there's quality on the data that you are putting out. Otherwise, when the data sets get to us, it's just trash in, trash out, and there's nothing of value that we can do. And you have to talk about roles and building those rewards structures for people to actually use data. And then lastly, it's about having some sort of roadmap and go about solving these problems, and having some sort of leadership structure for this to work. Okay. To finish off, I have 3 takeaways that I want to say. So the first one is, it doesn't matter if you're getting into data science. It doesn't matter what sort of team that you are building. It doesn't matter what kind of strategy that you want to have. The question that you should ask yourself is, where do I want to go? So define a clear vision and mission for what you're trying to actually build, and everything else will be natural. The second one is that data science is not only for data scientists, it's actually for everyone else around us. And so we have to tone down the words that we use and actually start communicating with people so that we can have some sort of traction and provide some sort of value. It's not just about technology.
I actually have a question about that, because my feeling on the role of data journalist is probably filling a gap that we have on talking management language, probably,
Yeah.
right?
Yeah.
So that's why it exists or it's needed to.
Yeah.
Yeah. Okay.
It helps with that. It has that role of actually building some sort of communication structure, which usually isn't there, but not every company can actually have that sort of person, and it's very special. It's a very special role, so it's hard to find also. And so we have to make this effort of actually communicating. Business people need someone to translate confusion matrices, right? Because they don't necessarily know what is a false positive. They know some sort of concept, but can that be, does it make sense in data science? It's a bit confusing. So we have to make this effort of communication. So the last one is that technology is important, but we must not forget that the value that we bring out is defined by business goals and not by the amount of technology that we use. And that's it. Thank you. Are there any more questions, or can we get? Okay, go ahead. Yeah.
I really love how you're bringing the design thinking to the process, building a bridge with business and the tech side. So I was going to ask you for a bit of advice. Not how many data journalists you need to throw at business for them to start understanding, but specifically, how would you engage those the stakeholders present in the design thinking workshop to start, to empower them to help more into the discovery of getting the business value and the business operations, and how we can make the techies work better with business? Because sometimes, it's not all the time, but sometimes you get those kinds of situations where you get, oh yeah, that's very nice, but you're the experts, you are the technicians, just do it your thing, you tell us.
Yeah.
And there's how would you advise to
start working on that, right?
Yeah.
Okay, so what I know is that that's a very specific role, and you only need a single data journalist. You don't need to start with more, really. And the key to solving those problems, it's the role of the data journalist is usually seen a little bit different from a data scientist. From a data scientist role. So usually people look at that role as someone who is not working with data. And so they talk with them a little bit differently. They don't necessarily think that they know everything about data and confusion matrices and performance metrics and so on. And that's exactly the mission of that person, to help go fetch the numbers, what it means to have a false positive, and talk with them and sit down with them and have that sort of conversation. And so the trick is to start with something like this. Here we don't talk about data science. We don't start talking about data. We start listening to the problems that they have. And as soon as they see that you're creating some sort of picture of the work that they do, they are in. It's done. Then you just have to pull the rope, right? And they start talking about the data that they have and the problems that they have, and then you start figuring out the opportunities that you have to solve some problems. And then you start talking about money. How much money can I save with this sort of, if I solve this problem? And they tell you that they don't know, that they have to fetch some sort of money table or something like that, and then you start pulling the rope a little bit more and tell them, okay, if I solve this problem with this sort of money, if I make a mistake, how much is it costing you? And they are in. And then you just have to work. Your way in, basically.
How many design thinking workshops would you recommend for a new customer, new project, a new initiative?
Okay, it's very tricky. It depends on the design thinking people. Okay, so in some of the projects with IBM, They brought a data journalist, and we did a workshop of 1 day.
Just one day.
Just 1 day. Very focused, very quick, very fast. Then in other projects, we actually have a design thinking team which does product design thinking, and we sat down with them to try to figure out how can we do data science design thinking. And that took a little bit more time because they use design thinking in a different way. And so we had to sit down with them and build all of this structure for us to work with data, because they normally don't use that in the other products, right? And that took like 1 week of sessions with a lot of people. It really depends on the project that you have. If you have a lot of people, then you have to have breakout sessions in order to listen to everyone. So it really depends.
Thank you.
Thank you. Okay.
Can I ask something?
Sure.
Lovely. You mentioned that one of the main challenges is about people and culture, right?
Yeah.
Namely the data literacy.
Yeah.
I was wondering if, when we talk about data literacy, I mean through the entire organization, right?
Yeah.
The managers and the scientists and the product managers.
Yeah.
Okay, so I was wondering what are the initiatives that you are doing to handle this, to solve this challenge, and if you are not doing anything about it, if you have anything planned to solve this.
Well, I don't have anything planned because I'm actually leaving the company. But what we usually do is, we figure out for the projects that we have, we figure out some sessions to share the work that we do. And we have to water down the kind of content because we don't want to go there with 1,000 different graphs and neural nets and how things work. People don't care about that. They don't know how the technology works. So we have to water down things and start showing the kind of work that we do. And in some of the projects, we sit down with people and show them like a 101 on data science. And show them how we do data science in very simple terms, and so we start with that. But that's not enough. But that's where we started, and hopefully it will continue.
I was asking because I know several companies, like your main competitor, not yours, but from a company.
Yeah.
And Galp, for instance, are training all the employees. And they should.
Because we had this team for 4 years now. We've been working with data a little bit longer, and we started seeing silos of data of different teams doing the same thing, using the same kind of data in different databases and so on. So people really need to be trained in there, and we have to figure out some sort of leadership that can see all of this, because there's a lot of duplicated data. There's a lot of data that is completely open and shouldn't be. And there's a lot of this, and you have to train people to understand that I'm coding some sort of software. I have to, I want to build my software with a set of practices, but I also need to think about the data that it's being produced and being stored somewhere. It's not just doing code stuff, right? But most people, I would say, that are still not inside of this this type of thing.
Some of them feel like they are data owners.
Some of them are. Some of them aren't. Some of them shouldn't be. Yeah.
I understand, and sometimes the data is all over the place, and sometimes it's repeated.
Usually is.
Yeah. So yeah. You're right.
Usually is. Okay. Anything else? Okay. Thank you.
Thank you.
Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born. The first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.